Hey everyone, we're back in my lab on a fresh install of Windows 10. Checking my email, I have some invoices that I should sign immediately. And after ignoring multiple security warnings and running this seemingly .pdf, I now have a reverse shell and I can start enumerating. While it's obvious this invoice.pdf file was malware, let's take a look at Elastic and see if we can uncover what it is and what it did. Here in Elastic, we have a slew of malware detection alerts, mostly flagging this file event for this invoice.pdf.scr. Navigating back over to the Windows 10 host, we can see this is actually a screensaver file type. And if we change our view to include the file name extensions, we can see the trailing .scr. These .scr files can be invoked the same way a .exe is, and if we look at the magic bytes, it'll reveal that this is really just a portable executable. As we can see, the MZ magic bytes indicating that this is a portable executable. Let's take a look at the Analyze Event option in Elastic and see the process execution flow. Here we see MS Edge spawning invoice.pdf, spawning notepad.exe. This alone is pretty suspicious. Seeing notepad spawn CMD is also suspicious. And clicking into notepad, we can see there's been one event. This is a network event. Seeing notepad making any network connections is additionally suspicious. And from here, we can pivot and see if this is a hollowed process or just utilizing the name. First, let's click into this network event and get some details about the process. The fact that it's executing from System32 is a good indicator that it's been hollowed. Let's begin by grabbing this PID and navigating over to Discover. I'll be using ESQL. I'll begin by targeting all my logs and then defining my condition. Process PID is an integer, so I won't wrap it in quotes. And I want the process name to be notepad.exe. I'm having some trouble with time ranges right now because I am in Arizona where we do not go through Mountain Standard Time, or where we don't go through time zone changes. So this happened at 12:05, although it is reported into my SIEM at 13:05. So I changed we're looking into the future now. But if you have a normal working SIEM, this shouldn't be an issue, and we can check. That was the process name here, notepad.exe. Process hash, this one doesn't have it, but this one does. Again, this is still notepad. Let's go over to VirusTotal and see what this hash is. Notepad.exe, so that confirms it appears as though, even though this is the legitimate notepad.exe hash, it has been hollowed to spawn command.exe and communicate over the network. That means even though the process memory of notepad.exe has been modified for a malicious payload, the hash is still the same, meaning the hash is gathered from the executable file that is loaded into memory initially and not the @memory runtime of the process. I already briefly demoed my payload with this reverse shell and the brief enumeration techniques that could occur. However, the code is available on my GitHub, and we'll go through it now. To begin, we include the standard IO, standard library, and Windows header files, and define the payload. This is a raw byte array of shellcode generated by MSF Venom for a stageless TCP reverse shell. Stageless important here, meaning I can handle it with basic netcat, and I don't need a second stage payload as my listener. The first thing we do is grab a handle to our current console and hide it so we can flash the console on screen and immediately hide it. Next, we define a handle for our process handle, a handle for our remote thread, and a D-word for our PID. We also define memory locations for our startup info and process information. This will be filled out on our create process call. Because we're spawning notepad.exe to be injected, we'll have to create the process first. We'll do this using the createProcess function in the Windows API. The first argument being the application name, the next being the command line, and these three being the process attributes, thread attributes, and inherited handles. Because I don't care about my command line or attributes or inherited handles, I'm leaving all of these as null or false. This create suspended flag is how you want the process to be created. In process injection, we'll create it suspended. That way, we won't have notepad.exe running to the user. The next two options, also null, the environment and current directory. I don't need to use any environment variables, and I don't really care about what my current directory is, so I'm leaving them as null. Next, we have the memory location for the startup information and the process information. This will be filled out once this createProcess method runs. Now we're going to open the process with the D word from the process information that was recently filled out. We'll store this in the process handle variable defined earlier. Next, we'll virtually allocate our memory, the size of our payload, with execute, read, and write permissions. Then we'll write our memory into this virtually allocated buffer. Lastly, we'll use our process handle to create the remote thread and execute the reverse TCP shell. Now, while we were able to confirm that this was process injection from the spawning of notepad.exe and the legitimate file hash, as well as malicious behavior such as spawning command.exe and network events, Elastic only alerted to the file writes, file, etc. Now, this is because of my policy. In Elastic Defend, I'm observing file writes, however, memory threat is a platinum feature, meaning the free version of Elastic doesn't leverage Windows API hooking and memory threat detections, and most likely flagged this file for the noisy payload and interactions with the Windows API. In future videos, I'll explore further defense evasion in a way that hopefully allows us to get this file downloaded without triggering any detections. Until then, we'll have to rely on users ignoring their EDR solutions.